Today I'm going to be talking about a project that was initiated by the Ontario Geological Survey in conjunction with Ministry of Environment, Conservation and Parks. And it involves adding the geological context to the provincial groundwater monitoring network. So the emphasis today is very much on the geological aspect of hydrogeological understanding. If we can get to the next slide, please, Rob. We're just going to quickly go through the background, a little bit about the types of data and the usage and users of PGMN, and then go a little bit into the ways we can start to integrate geological data into that network, and some of the sort of steps we're planning on taking on how to determine the stratigraphic intervals at the well screens and open hole intervals in bedrock wells. And then we'll quickly outline some of our thoughts on the path ahead as far as deliverables, products, and services that we can develop to make sure we're adding the best possible geological context to the groundwater network. Get the next slide, please. The PGMN is a network of wells across Ontario that was developed following the recommendations of an interministerial task force following prolonged drought conditions in the late 90s. It began in 2000. And it involves a partnership between MECP, conservation authorities, and partner municipalities. And the design of this network is so that there is a long-term record of trends in water levels and chemistry that can be shared with the people who need to know that information, like health units, other resource managers, consultants, and academia. It currently consists of 522 wells scattered across the province, and as you can see from the map on the right, they're mostly concentrated in the more heavily populated southern part of the province. If we can get the next slide, please, Rob. And of those wells, many sites are collecting additional data above and beyond just groundwater levels and chemistry. So we've got sites that were outlined by Heather Brody-Brown on Tuesday that include measurements of soil moisture, precipitation, stream gauge from adjacent water bodies, barometric pressure. Many of these are updated in real time so they can be integrated live. And all of these are extremely valuable information. If we can get the next slide, please. These data, just from a quick look on Google Scholar over the last 6 years, these data are being used as the backbone of many scientific avenues of research. So this is just a quick copy and paste of a series of papers that have been published in the last 6 years, just to give a quick snapshot of the types of investigations that are being supported by PGMN data, in addition to the core users, conservation authorities and municipalities. So these data are being put to use on a regular basis. Next slide, please. The PGMN collects information from wells hosted in sediment aquifers along the interface between the sediment succession and underlying bedrock, as well as bedrock wells. And those different types are shown on the map in the white, yellow, and pink dots. And you can see obviously a pretty strong correlation between the type of well screen or the material the wells are screened into versus the amount of sediment thickness, which are shown, the higher areas of sediment thickness are shown in the blue compared to low areas where bedrock is at surface are in the yellow. And what we've arrived at is the point where we realize there's no up-to-date and consistent stratigraphic information contained within the database. And that hinders our ability to correlate the trends we're seeing in water levels and chemistry across the network. And so that's what essentially the OGS has been asked to do, is to develop a way to add consistent and up-to-date and reliable stratigraphic information to the zones that we're monitoring within the network. So if we can go to the next slide, please, Rob. And there's multiple steps that we need to take to address this problem or this task. So step one is just taking a look at what information we have readily available. And we do have a series of maps that are extremely useful. We've got these on display in our conference room here, and they are available for free download through Geology Ontario. They're seamless maps that cover large portions of Southern Ontario, and critically, they're not just flat maps. There's a lot of information that is maybe hidden to some who might not know where to find it. So we're going to give a couple quick examples of how to put these to use, and if you can advance it, Rob. And we've also got, to help dive in beyond the sort of initial conditions, some 3D models that span large areas of Southern Ontario that will help to address some of these questions on the stratigraphic intervals at increasing depths. So we can go to the next slide, please. So we'll go through a couple of quick examples of the bedrock. So I've shown here a map of the distribution of PGMN wells in Southern Ontario, and I've color-coded them based on the mapped geology of the bedrock that underlies the well site. And if we can advance one here, so now what we're showing in the smaller circles are, again, the same legend, but it's showing the material described at the screened or open hole interval in the record. And what you see is it's probably going to be hard to differentiate, which is a good sign. That means that the material described in the well log actually matches with the mapped lithology. And there's a few areas where they don't match up, and in many cases, those are just showing areas where aquitard, so like a shale unit, was the first encountered unit, so the well has drilled down through that, or potentially some other areas where we might need to revisit and look at both the map or the well record itself. If we can advance to the next slide, please. We can take a quick look by integrating the PGMN data and the screen information by comparing that to our drift thickness map. So I've color-coded 3 categories here to show areas where the screened interval in the sediment-hosted aquifers are significantly above the bedrock contact. So the white are showing areas where we've got at least 35 meters of sediment beneath the screen, yellow showing areas where we've got more than 70 meters, and orange dots showing areas where we've got over 100 meters of sediments beneath the interval that's being monitored within the PGMN. And if we can go to the next slide, this aggressively colored map is one of the sort of hidden attributes of our superficial geology map that spans Southern Ontario, and it's color-coded to reflect the permeability of the superficial materials. So essentially what we're looking at is if you take the orange, yellow, and purple dots, those are showing areas where we've got aquifer material at surface. And if we can advance the slide, please, Robert. You can also combine that with the information on screen depth. So I've highlighted in red all of those wells where there's aquifer material or bedrock at surface, where the screen is less than 8 meters deep. So we can sort of get a quick sense of potentially more at-risk type conditions within the PGMN. The next slide, please. This map here is another example of superficial geology map, and it looks a lot like the map you would see when you first download the superficial geology. But this is something we just started working on to help address the questions we're being faced with. And the superficial geology map is coded based on the conditions that the sediments were deposited in. And what I've done here is we're starting to look at recoding the map so we can display the stratigraphic age or the stratigraphic relationships of the superficial materials so that it'll be more easy to integrate the superficial materials into a hydrostratigraphic framework. So this is very much in progress, but I'm encouraged as to how well the initial steps has gone, and this is going to be a big help in then going from superficial material down to assigning a named stratigraphic unit to the screened intervals. The next slide, please, Rob. So those maps are all very helpful at helping us understand kind of our starting point within the stratigraphy. The next step is significantly more challenging. We need to actually establish what we're sampling and what we're analyzing at depth. So the main goal here is to keep the workflow simple. So we're going to be looking at all the PGMN records, and for our purposes, wells without a water well record or reliable screen depth information are going to be by and large beyond our ability to look at in detail. So from that, we're going to be taking a detailed look at the wells we do have good location and lithological controls on. So we have a methodology outlined where, because we've got such good subsurface information in some areas, if you can advance the slide, please, Rob. We're going to take a quick example of the workflow for bedrock screens or open hole intervals. And then the next step is to look at, do they fall within a published 3D model area? And for areas where that is the case, if you can advance the slide, please, Rob, it's thankfully relatively easy. And I say easy right now because Frank Brunton and colleagues at the Oil, Gas, Salt Resources Library and the GSC have already done the legwork. So if you can advance the slide, please. Those of you who followed along on Tuesday would know about the three-dimensional Paleozoic bedrock model. This has been a massive undertaking, and along with it comes with a really detailed look at the data that goes into building this model. So it involves a huge amount of data synthesis and review, thousands of wells. This covers over 110,000 square kilometers, which also covers over 50% of the wells that are screened into the bedrock strata. So for this area, because they've gone through the process of cleaning up the database, assigning formal stratigraphic names, the wells that fall within this model area can be extracted, the stratigraphic interval can be extracted directly from the model itself, which makes life relatively easy, again, because they've done 6 years of work already to form the backbone of that. We can go to the next slide, please. For the quaternary systems, things are a little more challenging. Rob, if you can advance the slide twofold, please. Thank you. So even though we've got good model coverage across large areas of Southern Ontario, it's still not as straightforward of a process. You can go to the next slide, please, Rob. These models that have been completed span multiple resolutions, multiple scales, and contain different layers and different layer names within them. So although we have very good databases cleaned up and they're based on a lot of high quality geological information, there's still work to do to assign stratigraphic information or nomenclature that'll be relevant for people outside of these model areas. So if you can advance the slide again, please. So here's an example just from our OGS project areas. So these are 7 columns that represent each of our published or ongoing model areas. And I don't expect you to read all the acronyms or names, but it's showing you that even when you've got a consistent naming system in place, the naming layers don't necessarily match up because glacial processes operating at these scales span multiple time. The events span a long times and change across space. So I've highlighted in the dashed outlines the ATB1 unit, which in the areas west of the escarpment corresponds to a single unit, which is the Port Bruce Aquitard, a series of glacial tills. But that same acronym unit in areas east of the Niagara Escarpment in Simcoe County correspond to units that are about 6,000 years younger and deposited in a completely different setting. So there's work to be done to develop a nomenclature that allows us to bring all of the sediment deposits into a single framework. So if we can go to the next slide, please, Rob. And to do that, we really need to take a quick step back and really keep in mind who is going to be using this information and what kind of stratigraphic information is going to be the most helpful. So there's multiple ways you can build a set of names to describe sediments. None of them are going to work on their own, so it's going to end up being something that takes all of these into account. But the key thing is we need to develop something that is going to simplify the nomenclature that exists currently, because there are a lot of names out there, but also retain the meaning for people working at different scales of investigations. If you can go to the next slide, please, Rob. So this is just a quick summary of all of the named units that we have from our OGS models, which involve 32 different units overlying bedrock. And then on the left, you've got the units that are built into the Southern Ontario-wide model that's being built by the GSC in conjunction with ourselves. And probably we've got too much information in one and not enough information in the other. So we're ultimately working towards building some sort of happy medium. If you can go towards the next slide, please. So that covers sort of the outline for what we're going to do in the areas where we have three-dimensional model coverage, which is the easy part. And then wells that fall outside of those areas is going to be a labor-intensive effort of examining all available reliable information adjacent to those well sites and coming up with the best assessment as possible. And those assessments will obviously be lower confidence, and we'll be assigning confidence intervals to reflect that within the database we develop. If you can go to the next slide, please, Rob. So essentially, this is a major compilation effort, trying to get everything, all the geological and hydrogeological information out there available into one place. If you can advance it, please, Rob. Ultimately, what we want to produce, one more advance, please, is a single database that contains all of the well information within the PGMN and all of the relevant geological and hydrogeological information that we have available to us right now, so that people interested in asking questions or answering questions around these types of data have all of that information in one place. And if you can advance it again, please, Rob. And we want to feed this back into our very user-friendly geospatial data that we have available through OGS Earth and Geology Ontario. So it's we're using those maps to help inform this process, but then we want to deliver these results back in a easy-to-use spatial framework as well. And if you can advance the slide again, please, Rob. So there's a fair amount of things to consider. There's a lot of monitoring wells out there beyond just what's in the PGMN. So we're open to considering additional wells. We need to ask ourselves, what's the best way for our clients to actually access these data and make use of them? Are there existing products and services that are available right now that we can emulate? And I think the answer to that is yes. And critically, we want to hear from you. What information is critical to you that needs to be included in this? What sort of data do you need to see in a one-stop shop for hydrogeological information in Ontario? If you can advance the slide one more time, please, Rob. And that's the last phase. Is essentially we want to have a two-stop shop, essentially, because this project is being done in conjunction with the MECP. So the next steps are going to involve them in helping kind of integrate all of the information together. But we'll be building a database that links in the geological information that will be accompanied by a detailed groundwater resource study report. And we want to deliver these in easy to access maps and digital databases, which will be available through products like the OGS Earth, which we provide, as well as the MECP's portal, which is a very user-friendly tool. And ultimately, we're hopeful that this will, with your input, be a step towards improving our understanding of regional groundwater systems and making data readily available. And that's it for me. If you can advance the slide, there's our contact information. I think I've gone through that quickly enough to save some time. So there'll be time for questions, and otherwise I'll be happy to entertain any. Thank you very much.